Minute I'm trying to record this live stream and somehow my phone is not staying on the internet. So for this video we're going to talk about triangle mid segments, the theorem behind it, and what some questions involving it. So give me a minute when I pick a paper and start the live stream with you guys. So I'm gonna have to keep going to and from the phone to ensure that it's still recording and it's not stopping. So with triangle mid segments, there are things that is think about the parallel and transversal concept you learned before. Parallel lines, midpoints, half, one length is twice the other, and stuff like that. So the mid segment connects midpoints of two sides of a triangle. So when you think about your triangle, let's make it the thing larger. When you think about midpoints of your triangle, oh my word, this board. Oh, alright. So you think about midpoints of your triangle. So that's a triangle. And if the mid segment connects the two sides of the triangle, they connect from one side to the other. And so we say that this length, DE or DA, is parallel to PB. Alright, so these two lengths are considered to be parallel. And once you can identify that, you now need to know the theorem behind it. So the theorem says if a segment joins two midpoints, so a segment joins the two midpoints right here, let's call that Q. So the segment DA joins the midpoint of PQ and QB, and they're saying that these two lengths are considered to be parallel. So DA is considered to be parallel to PB. Alright? And they're saying that the length of DA is twice of whatever, length of DA is half of PB. So if DA was 4, we know that PB is going to be 8. Let's another example. If this length here was 10, we know the top part here is half of it, so it's going to be 5 here. So once we remember this theorem, we can answer any question that follow. The parallel aspect and the half and the twice aspect. We can do any question that follow. So the question here is saying triangle ABC is, as you see right there on the board, I think I need to zoom this a little more, but triangle ABC F and DE is part of C, and the list goes on. So we need to identify. So we need to identify the pair of parallel sides. So I'm going to be using markers to determine those for you. So the first one I see is normally the given one, which says DE is parallel to AC. And mine is not drawn to scale, so please forgive me on that one. So DE is parallel to AC. Alright, so that's one. We also know, let's change the color to give distinction. We also know that FE is parallel to AB. So FE is parallel to AB. And how I know that they're parallel, remember parallel lines run in the same direction. They never meet until they're superimposed. But on your triangle, we don't expect them to meet because of the concept we're trying to explain here. So we see that these two are parallel to each other, are running alongside each other. So we consider FE to be parallel to AB. And so the ones in the purple would be DF, and that's parallel to BC. So if you see DF right here, let's see if you can change the color again. DF right here, nope, that's not working. Let's put green. If you see DF right here, and that's parallel to BC along the line right there. So that's how you identify parallel parts. If you want to look at the smaller segments, for example, FE and AD, so FE right here, FE and AD, we'll see that these two are also parallel. If you look at DF and BE, those two are also parallel. So those are things that we look for when we are identifying parallel sides. So the example on this side, so they gave us triangle PQR, and they gave us some length on this side that PR is equal to 50, and ZY is equal to 15, and QR is equal to 36, and you're asked to find the measure of the missing segments. So for the missing segments, when finding the measures, what I always advise my kids to do is to label whatever you're given. So we're given PR as 50. So this length here is 50. Right? Then ZY is this length here. Let's change the color to have distinction. So ZY here is 15. We are also given, let's take a black. We're also given that QR, which is a long length here, that's 36. Alright? So once you identify that, you now need to know which sides are parallel and what you're asked. So I'm going to do the same thing I did for the first one here, and you'll see the parallelism coming out. Let's take, these colors are so distinct that just pick colors. So we know that PR is parallel to XY because they run alongside each other. Alright, let's use some curly lines. So this the next one. Oh boy. We also know that PQ is parallel to ZY. And I use some curly stuff to distinguish those lines. And we know that XZ is parallel to QR. So once we know that, we can now use the concept of it being twice or half the measure. So they want us to find PQ. So PQ, we know, I'm going to put it right here. Let me erase this side since I'm done with it. We know that PQ is parallel to ZY. So ZY is 15, being the shorter length, and PQ is going to be twice of this length. So PQ is going to be 2 times 15. Alright, so PQ is equal to 30. We know XY is parallel to PR, and so PR is parallel to XY. Alright, and so if they're parallel to XY, you know length of PR is the longer length, and that's 50. So XY is going to be half of whatever PR is. So XY is going to be half of, in this case, 50. And half of 50 is 25. So XY is equal to 25. I'm checking the phone to ensure that it's not. Okay, it's good. Alright, so PX is the short segment right here. So PX is parallel to ZY. That means they are running along the same path. And since that they are both short distances, we're short segments, we know that ZY is equal to PX, so PX is also equal to 15. Alright, so XZ is a segment here in red, and that's parallel. Let's put it up here. XZ is parallel to QR. And so QR we got to be 36, which is the longer length. So the shorter one will be half of that. So half of 36 is going to be the length of XZ, and half of 36, 18. So that's 1, 2, 6 is 86. So that's 18. So 18 is the measure of XZ, and that's basically how you simplify questions involving triangle mid-segments. The last one's asking us to find the perimeter of triangle, my word is moving, of triangle PQR. So I'm going to draw the triangle right here without the segments. So that's P, that's Q, and that's R. And we know that PQ is 30, so here is 30. We know that QR is 36, and that's 50. We also know that perimeter means the distance around a figure. Perimeter is the distance around a figure. So in this case, the distance around this would be 30 plus 36 plus 50. So it's 30 plus 36 plus 50. So 30 plus 30, that's 60, so that's 66 plus 50. 50 and 50 is 100, this is going to give us 116. So the perimeter of this figure is 116. I didn't write down the measurement, but you all know that whatever unit that's on it should be right. What is not responding? This is the first I'm hearing that. Alright guys, the whiteboard responders, give it a few minutes for it to respond. And it is still working. Okay, good. So, yeah, wait. Mute until it restarts. Open up again. Hold on guys, the board is somehow not responding to me. I think I'm writing too fast. I don't know. Ooh, what is that? That is sure not what I was looking for. Let's hope my work was saved and we can move on from there. Okay, it was saved. So this comes out to be 116. And so that's going to be the distance around this triangle PQR. I hope that part was clear for you. Remember, always identify the segments that are parallel. Then you know the long length is going to be half of the short, long half of the short, yeah? And the short is twice as long as the long one. Alright, so if you're asked to find the value of x with the same concept in mind, for this one, you need to remember which two sides are parallel and the theorem that falls behind it. So BA is equal to 3x and CD is equal to 9x minus 12. So we know that 2 of BA is equal to CD, right? So 2x of BA is equal to CD. So BA is 3x, so it's 2 times 3x is equal to whatever CD is, 9x minus 12. Alright, so from here, all we have to do is to simplify. And to simplify here, you basically multiply. So 3 times 2 is 6, so it's 6x is equal to 9x minus 12. And once you do that, you're now going to basically solve for x. So you're going to minus 9x from both sides. So we're going to have a negative 3x is equal to negative 12. From here we simplify by dividing by negative 3 on both sides. So x is equal to 4. X is equal to 4. And so that's how you basically solve for x when you're given a question like that. So you always determine which two lengths are parallel and the relationship between them. Alright? So this one is the similar one to whatever that was given to the first one, but this one, it wants us to find the length of mn. So we want to find this length, not just to solve for x, but to find the length of mn. So remember, 2 of mn is equal to bc. So it's going to be 2 times whatever mn is. In this case, it's going to be 6x minus 1, and that's equal to 13x minus 10. Alright? From here, we're going to basically simplify. I'm going to rewrite this because I need more space. So it's 2 times 6x minus 1 is equal to 13x minus 10. So from here, we're going to be simplifying. So it's 2 times 6x and 2 times negative 1. So 2 times 6 is 12x minus 2. If you don't know how to solve equations, go through my playlist on algebra, and you have some questions there that will definitely help you. 13x minus 10. So here we have to solve the equation with variables on both sides. So we have to basically reduce. Let's see if we can do this. So let's bring the 13 over. And then we can bring the 2 over. So we're going to minus 13x from both sides. That cancels. So that's negative 10. Bring down the negative 2. So 12x minus 13 gives a negative 1x or negative x. From here we're going to add 2 to both sides. So negative x is equal to negative 8. Then we're going to be dividing by negative 1 on both sides. So that cancels. So x is equal to 8. At this part you could either divide by negative 1 or multiply by negative 1, and your answer should have given you the same thing. Alright, so that's how you solve for a variable when you're given the mid-segment concept to take into account. First, you identify which two lengths are parallel, and once they're parallel, you know that one length is going to be twice the other, or half of one is going to be the other, or the shorter one is half of the long one. Alright? But here we found the value of x, but we want to find the length of mn. So I'm going to erase this section right here so we can find mn, as the question is not finished. Alright, let's go. So n is equal to 6x minus 1. So x is equal to 8. So mn is equal to 6 times 8 minus 1. 6, 8 is 48 minus 1 to give you 47. You know my diagram is not drawn to scale, so that's definitely not 47, but the concept behind it remains the same. So once you find the variable, you then put the answer for the variable into whatever you're trying to find. And that should give you what you're looking for, mn. In this case, mn is equal to 47. Alright, so with mid-segments, we also can be asked to find the measure of angles. And once you're asked to do that, you have to keep the concept of transversal and parallel line in mind. I drew this angle right here, but I'm going to draw it on that side so you can have an idea of what I'm talking about. So, read the concept of transversal and parallel lines. There are some proofs or some reasons you can use to describe why angles are equal, why they are supplementary, and the list goes on. So, based on the questions I've seen for triangle mid-segments, mainly corresponding and co-interior angles are taken into account. I'm put it over here. Corresponding, I see consecutive interior. Some people say co-interior. Yeah, corresponding blah, 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 blah. You see supplementary as a reason coming out. I know that's equal, the sum is equal to 180. You also see linear pair coming out. And a few other things. So I'm going to explain corresponding, consecutive, and the others before we get into solving this question. So in my opinion, once you understand the concept of transversal and parallel lines, you should be able to answer a question that involves you solving for the angles. So this was taught as a prerequisite, and your teacher should have done that as well if you're watching from someplace else. Should have taught the corresponding angle classification and properties before you get into this. So let's go. So corresponding, I'm going to label this as some angle measures. We're going to talk about which are corresponding and whatever the case is. Alright. So let's use the red. So 1, 2, 3, 4, 5, 6, 7, 8. So if you think about corresponding angles, we say corresponding angles are equal. And they're equal because if you should cut this transversal, whoops, I keep moving the word. Cut this transversal. Come on. I can't erase you. Alright. If I should cut this transversal into two equal parts, as in right here, and I bring the bottom part to fit on the top part, you will realize that angle 1 is equal to angle 5. You'll see that 2 is equal to 6. You'll see that 3 is equal to 6. And you'll see that 4 is equal to 8. And those are corresponding angles. So once you can cut this line into two equal parts and bring the bottom part to the top or top to the bottom, and it gives you the same answer, so you know that they're corresponding. So for consecutive interior angles, what's the matter? For consecutive interior angles, you will see these between two parallel lines with the help of a transversal. So we always tell this, well, I always tell my students to look for the C as consecutive. So the C that you see right here will give you a hint which two angles would be considered as consecutive interior. So I'm going to show you what I'm talking about. It can be on both sides of your transversal. So right here, I drew a black C and a red C. So these two angles, 4 and 6, their sum, if you add them, should give you 180. And the same thing for 3 and 5. If you add them, their sum should equal to 180. Alright, so we know that angle 4 plus angle 6. So angle 4 plus angle 6 is equal to 180. And we know that angle 3 plus angle 5 is also equal to 180. Alright? And so supplementary basically saying that two angles added need to give you 180 when they're formed on a straight line. Either you have two of them or more than two. Linear pair, I'm gonna erase this and show you guys those two concepts because it's kinda break my chain of thought when I drew that. So for the linear pair, they're saying that two angles, angle A plus angle B, needs to equal to 180. And supplementary can be drawn on that side, can be drawn this way. However you see it adding up to 180 on a straight line. Ooh, ouch. That's basically what supplementary angles are. Alright, so having the concept there, this thing hurt my foot. Wow. And that's painful. Alright. I am going to extend these so you can see what I'm talking about when I say parallel and transversal. So let's say we extend the parallel lines further out of our triangle, because you can do that if you want to. There's no right and wrong way of doing that. You'll realize that thinking about corresponding, you'll see that these two, 1 and 5, angle 1 is equal to angle 5 because they are considered to be corresponding angles. You will also see that angle 2 is equal to angle 56 because again they're corresponding angles. You'll also see that the C that I spoke to you guys about when I was explaining that, the C would be right here. So you'll know that angle 3 and angle 2 both should give you 180 when you add them up. And you'll know that 144 and angle 1, so angle 1 plus angle 144 should give you 180, as these are consecutive, and I can spell this word, consecutive interior angles. Alright? And so we say that these are co-interior angles. You'll know that angle 5 and 4 and 114 will be linear pair or supplementary as they form on a straight line. So with that concept in mind, we are now going to move on to solving these questions. So I'm going to erase this section here where I explain the back concept to you. So I'm going to find angle 1. I'm going to find angle 2. I'm going to find angle 3, angle 4, and angle 5. So let's go. So angle 1 is the one that's down here. So I'm going to say 180 minus 144 to give us some number. Is that 30 something? I don't know. Let's see. I don't know the answer to that, guys, in my head. 36? Maybe. Let's prove it. 180 minus 144 gives us 36. So the angle right here is equal to 36. Because they are consecutive interior angles. Alright, so let's go for angle 2. Angle 2 is the angle on this side. We see that angle 2 is equal to angle 6, as we established here, because they are corresponding. So angle 2 is equal to 56 degrees, as they are corresponding. Angle 3 is the one above that. So there are two ways you can work angle 3. You can say 180 minus 56, which is your angle 2, or you can say 180, same thing, minus 56, which is your angle, which is the 56 above it, to give you the linear pair or the supplementary. So let's just stick with this one. It says 180 minus 56 to give us some number, which I don't know. So it's going to give us 124. So angle 3 is equal to 124. Angle 4 is at the top. Angle 4. I'm going to find angle 5 first, before I find angle 4. I'm not thinking of the reason of that right now. So let's find angle 5 first. So for angle 5, I'm going to say 180 minus 144. I can't press this number, okay. And that gives us 36. But it's even right here. Angle 5 is equal to angle 1. I didn't even see that one. So I wouldn't work it. So angle 5 is equal to angle 1, so that's 36. So for angle 4, there are several ways of working this. You can use your extended triangle by saying 156, so it's going to be 180 minus 56 and whatever angle 5 is. Minus 56 plus 36. So 56 plus 36 is equal to 92 minus 180. And that's equal to 88. So angle 4, I need space. So angle 4 is equal to 88 degrees. How I got this one? Because the angles in a triangle add up to 180 degrees. So my triangle here would add up to 180 degrees. So I know this one, I know this to be 36. So if I add these two and subtract from 180, then I'll get my answer to be 88. And that's how you find the missing, oh boy. That's how you find the missing angles of your triangle mid segments. And let's see if I have another question for you. Nope, I don't. And that's the end of this live stream, guys. I hope it was useful for you. I know one person was not here and they asked me to explain it for them. And I hope this makes sense. So always remember the concept of parallel and transversal lines when you're going to find the measure of whatever angle you have missing. Once you remember the concept, you can always extend your triangle to look like your transversal when you're basically going to be working this. Alright. I'm going to start another video, guys, because I'm going to explain statistics, regression equation for some people who were absent from school. So thank you very much for joining. Feel free to come back in the next minute while I explain regression equation for another student who has been absent for a while and cannot make it to the what you call it again? Cannot make it to the rotate your phone backwards. Okay. The kid cannot make it to. I'm gonna have to do it for him on the board. So I'm gonna start that live stream like right after this one. So feel free to come back if you want to. And if not, I appreciate you being here. Thank you very much for joining me. And here I go to get my computer to get the question that I want to explain. As you know, my brain can't hold so many stuff. But we're gonna make it work. Don't worry. I don't want the live stream to be too long as well for the person who asked me for that question. So that's the reason why I'm creating another live stream to explain, oh my foot hurts, the other concept. So I'll see you guys in about 3 minutes.